So here in this linear unit, we're going to talk about slope and what it is. And linear functions always have a straight line, and the slope has to do with how fast it is growing, and it's growing at a constant rate. That's what makes it linear. So slope is how much is being added or subtracted each time. You might want to stop the video and figure out what figure 0 is and figure 4 is, and so we can talk about slope in this context. So I drew figure 0 and figure 4, and we see that for each figure we're getting 1, 2, 3, 4 more, 1, 2, 3, 4 more, 1, 2, 3, 4 more, etc. The slope of this particular thing is 4 for every figure. If you're interested in the whole rule, in this case, there's one more piece we have to pay attention to: the 0 figure. And the 0 figure, since it started out with just 1, it's the 4 that it's adding each time. So 4 for the first one, 4 for the second one, 4 for the third one, plus the 1 remaining one. So slope is how much is being added or subtracted each time. So here in this money situation, we have how much money we're starting with, and then the slope is how much we're spending each day. So the slope in this case is going to be negative, and it's negative $3 for every day. We see right here that I've made a graph of it, and you could use a slope triangle if we didn't already know that it was $3 for every day. You can see that it drops. I'm going to blow this up a little bit. It drops 3 for every 1 day. So that's our slope, $3 a day. And if we wanted to write an equation, once again, we start with the y-intercept with a 0 term. And so it would be 15 is what we're starting with, and we're dropping by 3 each day. You could also write it in y equals mx plus b form. So our m is always right next to the variable, and here is our starting amount, so negative 3x plus 15. So here we're looking at slope that we can calculate using a slope triangle. Slope is always going to be the change in your y's divided by your change in x. We call that rise over run. And you'll also see me use this symbolization, change in y over change in x. It's called delta. It's a scientific way of talking about change. It's just faster than writing the word change. So A, we're going to look at that one first. I'm going to blow it up a little bit. Or not. Or not. Okay. The vertical distance for A is 4, and the horizontal distance for A is 2. So if we're looking at A, we get 4 over 2, which is the same thing as 2 over 1. So the slope of A is 2 for every 1. B is also positive. All 3 of these have positive slopes. Remember, they're heading up, so they're positive. And B has a vertical of 4 and a horizontal of 4. So the change in y is 4, and the change in x is 4, and we can simplify that as 1 for every 1. So the slope of B is 1. C is going to have a fractional slope. Once again, we look at the vertical, and the vertical is 2, and the horizontal is 4. And when you're counting, by the way, you're counting the space. You're counting the space. Space 1, 2, 3, 4. You're not counting the lines, you're counting the space. So 2 for every 4, which we can simplify as 1 for every 2. And we're going to spend time in class. I could have drawn a slope triangle right here, and there's 1 for every 2. And I could have drawn the slope triangle for that one right there, and I would have gotten 1 for every 1. So you can draw different slope triangles, but on each line, they're all going to simplify to the same simplest one. So the simplest form for C is 1/2, for B is 1, for A is 2. So if you wanted to find a slope from a table, you don't want to graph all the points and find a slope triangle, then you can go ahead and look at the same things. You can look at the change in y. Here we're going to look at the change in y. 5 minus 2 is going to be 3. So it's dropping by 3. This is supposed to be negative 1. That's supposed to say negative 1. And it continues to drop by 3. So it's dropping by 3 each time, showing that it's a linear function. And then on the x's, it's going up by 1. So we have a change in y of negative 3 and a change in x of positive 1. So the slope of this one, which we call m in the, or a, depending on what book you use, m is negative 3. That means it's dropping 3 for every 1. Got to pay attention to both the x and the y. And here's an example y. Here we have a drop in 3. Again, 5 minus 2 of the y's is going to be negative 3. This, once again, is supposed to say negative 1. I typed it wrong. 2 minus 1 is negative 3. So this one drops negative 3 as well. But it drops negative 3 for every, it goes up 3 each time. So it's dropping 3 for every 3 it goes up. So when we simplify this one, we're going to go ahead and get, you can divide both the top and the bottom by 3. And you're going to get negative 1 over 1. So this particular one is a negative slope of negative 1. So as we're learning about slope, it's important that you remember that the slope is always multiplied by the d for days, or the x for whatever, or the n for the figure number, because it's always being added over and over and over again, d times or x or n times. So if we're going back to the money one where I was spending $3 a day, I would be like 15 minus 3 minus 3 minus 3 minus 3, or 15 minus 3 4 times. So x days of me spending money would be the 15 I started with minus 3 times x, and x once again is the number of days. So the slope is always going to be attached to the x or the d or the n.